This packet deals specifically with U subproblems that involve exponential and log equations, so it's kind of a special case of the last video. Things to look out for: fractions, like number 1, and exponential problems, like number 2. So what we will typically do for problems like number 1, when problems are fractions, usually we want to let u be whatever's in the denominator. And with exponential problems, there's something that we need to do first on this problem. I don't want that e to the x squared to be in the denominator. I'm going to rewrite this, because e to the x squared in the denominator is the same as e to the negative x squared in the numerator. So oftentimes what we're going to do with fractions, and notice on this problem there's no clear inside-outside. I don't have something like, if this was raised to the 4th in the denominator, I might treat the problem differently. But if we just have a fraction, no parentheses, no exponents, we're typically just going to have u be equal to the denominator. And down here with exponential problems, like e to something, e to the function, u is typically going to be that exponent. And notice we do want to do a preliminary step. If in the case where e is in the denominator, you do want to bump it up to the numerator before you begin. Otherwise, the problem just gets messy. So using those expressions for u, oh, I didn't write it for the second one. For this one, we're going to let u be negative x squared. You can go ahead and try both these problems. So pause the video, try the problems. For number 1, the final answer is going to be B. And for number 2, the final answer is going to be C. For the first problem, if u is x squared plus 6x, then your expression for dx should be du over 2x plus 6. So our substitution, I have x plus 3 over u. And looking at that x plus 3, I'm going to write this 2x plus 6 as 2 times x plus 3. So it is a little bit more clear that we can simplify. And once we have that, I'm going to give myself a little more space. We do need to remember to rewrite the a and the b. So if x is 1, if I plug 1 into x squared plus 6x, I get 7. And if I plug 3 into x squared plus 6x, I get 27. So now what do I have? I have 7 to 27, 1/2 times 1 over u. So this is where ln is going to come into play. The antiderivative of 1 over u is ln u. So this is where that answer B is going to come from. It's just a rewritten form of this. On this problem down here, number 2, and I'll give myself the space because I think I'll want it. On problem number 2, if u is negative x squared, then your expression for dx should be du over negative 2x. And our integral becomes, so I have x e to the u times du over negative 2x. We can see those x's. So I'm going to have a negative 1/2 times e to the u du. 0 to 1, so if I plug in 0 to negative x squared, I get 0. And if I plug in 1 to negative x squared, I get negative 1. So to flip those, 0, negative 1, remember we just changed the sign, so it'll be a negative 1 to 0. But we see these negatives here, negative, negative, so I'm just going to have negative 1 to 0 of 1/2 e to the u du. The antiderivative of e to the u is e to the u. So I have 1/2 e to the u going from -1 to 0. And I'm very quickly running out of space. There we go. So 1/2 e to the 0 minus 1/2 e to the -1. E to the 0 is 1. E to the -1 is 1 over e. And it looks like with their answer, they just factored a 1/2 out of the expression. For number 3, the answer will be D. And this problem, it's funny, this problem looks a lot more complicated than the last one, but it's actually going to be more straightforward. So if we let u be the exponent, so if u is sine x, du dx, the derivative of sine is cosine, so I'm just going to write du over cosine is dx. So my integral, so I have cosine x e to the u times du over cosine x. Simplifies nicely. And these endpoints, 0 to pi over 2, sine of 0 is 0. Sine of pi over 2 is 1. The antiderivative of e to the u is e to the u, and we're going from 0 to 1. E to the 1 is e minus e to the 0, and e to the 0 is 1. This problem actually goes back a couple sections to the last packet. So with number 5, and there is a note on the worksheet to skip number 4, that's no longer being covered on the AP exam, which is nice, and we hadn't covered it anyway, so double nice. So for number 5, we know big F is our antiderivative of this. We know f of 1, we're looking for f of 3. So this goes back to the fundamental theorem of calculus. Oh, to give you an answer first, in case you don't need the explanation, the answer is A. So we know that the integral of ln of sine squared x plus 3. We care about the x values 1 and 3, so I'm going to go 1 to 3 equals f of 3 minus f of 1. Be very careful plugging this into your calculator, especially that sine squared. There's a lot of parentheses on this problem. So I'm going to have ln of, to plug in sine squared, we have to plug in sine x squared, kind of like this. We're looking for f of 3. We know that f of 1 is 2. So be careful plugging this into your calculator, but make sure that you're able to do that. You should get 4.595. And that's how we get that answer of 6.595.